Okay, welcome back once again. So today on the last section, that is 9.4, we are comparing two population proportions. So here we have two populations for which we've drew some samples from them. And when it comes to the population proportions, it's always some kind of independent and large sample. So we have large independent samples that we might be dealing with, but we can affirm this. We can affirm this using our rule of thumb, that is NP should be greater than that of what, greater or equal to 5. That tells us that we are gaining large sample. That is for proportion. But I think for some kind of examples that we are going to do, we believe that all the samples that we are going to pick is a large sample and they are independent. So for proportion, we are dealing with large sample independent. It works the same as the mean. Nothing is changing. If I'm using mu1, mu2 for population 1 and population 2, then I'm going to use p1 and p2 for what? Population 1 and that of what? Population 2. But here it is in terms of what? Proportion. That is it. And if I want to get an estimate, a point estimate for the difference between these two proportions, then is p hat 1 minus what? P hat what? 2. That is the same thing. And how do we get our p hat? Is our success over the sample size that we're having. That is how we get our p1. Okay, so as you can see here, that is how we get our p hat. So if you have two populations, then p hat 1 is equal to s1 all over n1, and p hat 2 is equal to that of s2 all over what? n2. This is our success, what we are interested in, all over the samples that we took. That gives us the proportion. So the proportion is focused on what you are interested. So listen to the question, and the question is going to give us what you are interested, and we calculate the confidence interval based on what you are interested. Okay, all right. So if you want to get, so this estimate p1 and this estimate p2, if you want to estimate their difference, the point estimate for p1 minus p2, then it will be what? P hat 1 minus what? This is the same thing. Nothing is changing. So this will be the point estimate. And we can construct confidence interval for it as well. Interval estimate. So our goal is to use the information to estimate, all right, the difference P1 between the two population proportion and to make statistical valid inference about it. And if you understand the mean approach, the same work for the proportion. That is, if you understand that of the large independent samples for the mean, that is 9.1, you should understand 9.4. It is the same approach that you are using. Nothing is changing. And in creating a confidence interval, here to use the two sample Z, the two proportion Z interval. For the mean is two sample Z interval, but for the proportion is two proportion Z interval. Then that you input your statistics there, you are good to go. So in this example, we've been given the statistics. We have N1, we have P hat 1. Then in the question, you do such. So if you click on your calculator and you click on start, go to test, choose that of two proportion C, two proportions. So we are going to do what is one proportion. We've done that. So two proportions Z interval. Then we get our S1, N1. We are good. S2, N2. Then we get to calculate. It gives us our interval. Very simple. Very simple. And the point estimate of that is that. So in the question, if they tell you to give a point estimate, it should be this. Okay, so we are good to go. Right. So just if you are not interested in the final answer, maybe I might be interested in this. This is what I'm interested in the final answer. Then you have to work it step by step. The calculator always gives you the interval like that. A value here, another value here. That's what the calculator does. But if you have to do it manually and I want a plus or minus this, then you have to go through the step-by-step approach. So that is for it's nothing changes. What we know for the Z alpha is the same as how we calculate the Z alpha over 2. Nothing is changing. If you have 95 confidence interval, then the Z alpha over 2, we know what it is. But if you have 90 confidence interval, then our Z alpha over 2 will be 1.645. So in this scenario, we're doing such. Okay. Okay, then we come to the hypothesis testing. So just as we did for the mean, we realize that mu1 minus mu2 equal to some d naught for the h naught. But the alternate hypothesis has the three different ways of writing it. And this is determined in the question. Within the question, they tell you to test. Then you have to go through the 5 approach. Okay, then you determine your d naught from it. So you have to know if the first row will be your first population, the second row might be your second, or the first column. It could be arranged in column wise. Note that we can also arrange them in column wise. You can go this way, maybe pop 1, pop 2. Okay, you can have data like this, or the sample statistics. Maybe you have N1 and you have our p hat 1, and okay, we have N2, we have our p hat 2, okay, p hat 2. So it could be arranged this, or it could be arranged like this. Let pop 1 or pop what 2 is the same thing. So the first one that you see might be your P1, and this will be your P2. Okay, that is that in writing the hypothesis. Okay, so you always want to write it just as you see in this formula. It's always written as P1 minus P2. We don't write it P2 minus P1. We don't write this. Okay, we don't write this. We want to write it like this: less equal to d naught for h naught. For h naught, that's what we are writing. That's what you see. But for each one, we use 3 different signs. So the same thing. Then, if you're able to determine, then we determine our z value using the formula that we see. But in the determine the z, we don't use the 2 sample z test because it doesn't work. So in the proportion, you have to work it manually using the formula that we see. The z test never works, so I beg you. But in the mean approach, it only works when d naught is 0. When d naught is not 0, it also does not work. But for proportion, whether d is 0 or not, it does not work. So do not use it. Although the calculator has it, but it does not work. Please note it very well. All right, so we have some examples, and based on the construction of it, we're able to calculate our z. So here we have to work it manually, okay, based on the statement that we have. Okay, so if we are to consider our previous table, so we have the previous table here. So we have no public web, so this would be our P1, and this will be our P2. Okay, population 1, population 2, or the proportion 1, proportion 2. Okay, so which one are we saying that has to come first to construct our HA? So we have to test whether there is evidence to conclude that the public web access. So the public web access will be our P2, right? Okay, that is the second row. So our P2, we are formulating our hypothesis. So our P2, or is it? Okay, so our P2 has increased the proportion of that passed on the first inspection by more than 5 percentage points. So has increased. So P2 has increased. So we are comparing. So this is greater than what P1, but there's one more additional thing: has increased the proportion of projects that pass on the first inspection by more than 5, so plus what? 5 percentage points. Okay, so we have to rewrite this back to what? P1 minus P2, and this will be under HA. So if you're able to rewrite this back as that, so that is what we did, and we're able to do it. Okay, let me test at alpha equal to 0.1. Right, so we have our d naught to this. So our d naught here is not 0. It could be that it has increased, and that was it. If it has increased, then it will be P2 greater than P1. We don't need any additional information to get our d naught. So our d naught will be 0. All right, so that is that in getting. Then determine the rejection region. You know how to do it. It does not change from what we've learned early on. We know how to do it. So learn what we've actually, chapter 8 or chapter 7, you know how to get our rejection region and our p-value. Nothing is changing there. All right, so here we have to get a point estimate for the difference. So point estimate, like I said, is p at 1 minus what? okay, and construct a nice confidence interval. So if you get this point estimate plus or minus a minus margin of error, we have the formula there and we have to test. So we write our hypothesis, get our z value. So note for two proportion, we don't have the z, we don't have a shortcut to it. You have to work it manually. Okay. We have to compute the p-value of the test. So if you get your z value, then you have probability of z greater than what? The value that you had. It's either less than the value that you had or greater than, based on the direction under HA. So if HA, you have less than under it, use the less than here. If you have greater than under it, use the greater than. But if you have not equal to, then I'll let you use the probability of z greater than that value. But after that, multiply your answer by 2. Multiply your answer by 2. So we can use the, if, okay, let me make this clear. If under the HA you have not equal to, then based on the z, if z is negative, then we can go to the negative approach, then z is less than that value, okay, to get the p-value. But if the z value that you had is positive, then use probability of z greater than that value. Okay, but yeah, I think that should work perfectly. Then you multiply your answer by 2. Why am I saying so? Because you are going two directions. Okay, and the z value that you had, since it could be negative, it could be a negative z value, or it could be what? A positive z value, and you want to get the area here. We want to get the area, so this is the area that we want, so you're going this direction. If it is negative, we want to get the area here, so you're going this direction. This is when it's not equal to. So if it is negative, then you want this area, so you use this direction, you use the less than direction. But if it is, the z value is positive, use the greater than direction. Okay, then you multiply that answer by 2 because it's not equal to two directions. All right, so that is that. Then you make your conclusion and you are good to go. So the same thing actually applies. So compute the p-value of the test. And the p-value you use, if you want to use the calculator, is normal, the normal CDF. Okay, then you put the lower value here, the upper value here, 0 and 1. Then you're good to go. Here's your p-value. Okay, so that is that. There's nothing changing here. So based on the claim, and okay, so these are just examples of, in case you're going through and you don't understand anything, please let me know. So always H for two sample, the HA uses the equal sign, and the H not uses the equal sign, the HA uses 3 different approaches of writing it, and we determine that through the question. Okay, determine that through the question. All right, so that is that. Thank you very much, and I appreciate your contributions and everything, your attention in class and everything. And I'm hoping that you succeed in this course and pass well in the last test. All right, bye for now.